Hello everyone. In last video we saw two models, that is illumination model due to the ambient light and diffuse reflection. Today we'll see next model. So this model, it is using the specular reflection. So if object is having very shiny surface, then from shiny surface it reflects more light. Okay, sometimes if surface is more shiny, more smooth, then we can observe some bright spot on that particular surface. So how we can calculate the intensity for this? That can be done with the specular or specular reflection, or it is called a specular reflection model. So light reflected from a certain spot on the object is concentrated and appear as a lot brighter compared to other spots. So this is due to the specular reflection, and it is important property of shiny objects. So here you can see two diagrams where one is having the some rough surface and one is having shiny surface. Then you can see how the light is incident on the surface and how the reflection is done. In shiny surface, reflection is done in very concentrated way, whereas in diffuse reflection case, the reflection is done in many directions. When we observe the specular reflection, then viewer position is also very important. If viewer change the position, then we can observe the different reflection or different light with the different intensity. That's why in the specular reflection, viewer position is also important, whereas in diffuse reflection, viewer position is not the important one. So how we can model this specular reflection? Here there is a diagram, here there is a surface, then this is a normal vector to the surface, then light incident from this direction, and then it is reflected in opposite direction. Incident light is making angle theta with the normal to the surface, whereas reflection also making the same angle with the normal. Then here we are going to consider the another vector, that is a viewing vector. So V is the position of viewer. So that vector also we need to consider. Now this viewing position, it may be changed based on the viewing position, the intensity will be changed. Now here we can see that viewing vector is making angle phi with the reflection. So the specular reflection is visible only at the direction close to R. If viewer is at nearer to the R, then viewer can observe more brighter light there, and if it is going away from the R, then that brightness is going to decremented. So how we can model this? The specular reflection range, it is specified with the exponent. Shiny surface is having the large specular reflection exponent, that is ns, where it is almost equal to infinite if it is shiny surface. So ns will be very large, whereas it will have very smaller value when there is a rough surface. So ns is infinite for a perfect mirror, and for rough surface its value is almost near to 1. So here specular reflection can be given with this value, that is ks into il into cos phi raised to ns. So this ns factor is very important. For shiny surface, this ns should be very high. If it is having low value, then its brightness is going to reduce as ns value is going to reduce to 1. Ks is the reflectivity of the particular surface. Il is the intensity of incident light. Now we can rearrange this cos phi term. Intensity of specular reflection depends on the surface material properties and the angle of the incident theta. So this can be expressed as a coefficient W theta. So for case we can write W theta. This W theta, it depends on the surface material property as well as the incident angle, and which value can be found experimentally. So as per the Phong specular reflection, we can model this as a W of theta into IL into cos raised to ns phi. Cos phi can be considered as a dot product of VR. VR is what? V is the viewing direction, R is the reflection direction. If we consider unit vector, then cos phi can be replaced as dot product of VR. So this expression can be changed and we can write the expression as Ks into IL into V into R raised to Ns. So this is also called a Phong model, which is used to calculate the specular reflection intensity. So if there is a specular reflection, so obviously there will be some other reflection also. So we can add the reflection, or we can add the light effect due to the ambience, as well as we can add the diffuse reflection also. If we combine, it will give the combined light effect from the surface. Now here there is another representation of the specular reflection. As we are using all these vectors, that is L, incident of the light, then N is the normal to the surface and V is the viewing direction. So here we can consider the halfway vector. Halfway vector is the halfway of vector L and V. So halfway vector can be calculated as H equal to L plus V divided by mod of L plus V. So mid vector can be calculated from L and V. So this H vector is making some angle with normal vector, and then the same term can be represented in term of halfway vector like Ks into IL into H into N raised to N. So it is easy to compute compared to previous one, and it gives the same result. So same model can be represented with in term of halfway vector. So here you can see the example how the specular reflection looks here. Here in this surface you can see the bright spot. So such kind of spot we can observe in real time objects also if the surface is very smooth. For example, if there is a metal glass, so we can observe this kind of bright line. So this is what the specular reflection, and this is what when if we combine all these, then we'll get final intensity of the light. So this is what about the specular reflection. So in next video we'll see the shading concept.